Hi, today I'm going to discuss with you the virus and the virus that causes Wuhan pneumonia. And the name of the virus is called 2019 novel coronavirus. And before we go into the detailed discussion on the virus, let's have an update on the cases of the Wuhan pneumonia. At this moment, about 43,000 cases, and the death numbers past 1,000. And looks like the trend still climb, and this is total cases, and as of today, and this number is continue to increase, and also total deaths, the number also is also increased. And don't know if this number, how far this can be go, but looks like they need to go another 1 or 2 weeks. And one good thing is that the daily case, and also for today, February 10th, that case is close to 2,500, is still continue to drop from the February 4th higher, and that's a good thing. I wish that number will continue to drop. And today, as I mentioned, today is February 10th, and actually today in China, it's the official day. They're going to start work. People go back to work, and that is a really big challenge. And I mentioned that may not like before people leave Wuhan. There's millions, 100 million people leave, and now there are also millions of people go back to the work. That bring a huge challenge for people to control this epidemic. And it's kind of a balance between economic and health. And if I was decision maker, I try to let this number, the new case, drop to a little bit far before to allow people to start to work, because everyone go back, and the case of new case, this chance the new case is going to increase. But anyhow, it's a very, very hard decision, and it's kind of balance between economy and the health, and because it's very important for people to work to create active economy. But on the other hand, and health issue also is very important. But it is hard to keep the balance. And now let's talk about the virus. And yeah, this is the virus which causes Wuhan pneumonia, and it's called coronavirus. And inside the virus is a core. This is a viral RNA, which is encapsulated by the nuclear capsid protein. So the nuclear capsid, just like the human brain cell, is very, very well protected. And outside of virus, and there's some lipid, this membrane, and which is called here this membrane protein, and here this lipid bilayer, and also outside the virus this is spike protein, and this is side which is the virus binding to the human cells. So here just show how this virus gets into the human body. And so this is the virus. It can get through into the human body through the respiratory tract, and also go through the mouth. And should point out, as soon as the virus gets into the human body, either through the nose or through the mouth, and they can replicate in epithelial cells, and then the virus become more and more and can slowly or transmit to the lungs. And that this virus is very adapted to the lungs of the human. So this is one big difference from other viruses like influenza virus. So because this virus causes much more lower respiratory tract infection, that is called infection in the lungs, and that's the main reason that cause a lot of trouble. And so here just show this replication cycle of the virus, and just this entire process just drove in one cells and one virus, and just for easier for you to understand how the virus replicating within one cells. But that can happen in thousands or million cells and million virus in the same time. And this virus spike, and this is receptor, and on the cell, so the virus spike binding to the cellular receptor, and then the virus can get into the cells. As soon as getting into the cells, the virus uncoating, the removes outside of membrane and release this genomic RNA into the cells. And the virus only carries this RNA-dependent RNA polymerase. And so carry this polymerase and also genome, and use everything from cells, use cellular machinery to turn on this transcription and the replication of the genome. So first start transcription, produce all different messenger RNA, which will now produce all the structure proteins of the virus, like spike protein, envelope protein, and the matrix protein, and the nucleocapsid protein. And this is just like a assembly manufacture factory, and the entire process is non-stop and continue all the time. And meanwhile, they also do some replication, the genome, and use this as template to produce this genome. So when all this materials was generated, and materials is assembled on, you can use cellular machinery, and this spike, matrix, and also memory protein start assembly on this endogenous reticular membrane and form kind of primary forms of the virus membrane. And also this genome is encapsulated by the nucleocapsid protein, and this two parts have kind of singular, slowly assembled on this membrane. And this then goes through all the way through this cellular membrane system, and the virus was slowly assembled. When this virus was completely matured, and then going to release from the cells, and the entire process is continuous without any stop. So, and the virus, all this proteins and all this genomic RNA is produced all the time, and the assembly process is non-stop, and there's always a new virus come out, and then this will be released out from the cells. And from one cell is potential to release thousands of even millions of different viruses, and this virus then and released and going to infect new cells. So as soon as this machine of virus generation is created, you can see this so powerful. This virus will generate millions and billions of trillions. And if just because the virus is something new, the human body actually have any defense against this virus. So that's why it can so easily spread among people. And so the virus is really going to be a very, very, very effective ways to generate a cell. Okay, today I'm just talking about this virus, and hope to see you in my next video.